one frame it is here, and then the other frame it is here. So it's not hitting that wall for it to bounce back. So that is why your water voxel sometimes just gets passed through. So even though we are putting it at play every frame, so because it is too fast where the frame is one is here, so the next frame is already outside of your container, of your basin. So what step size does is it's add in more simulation in between that one frame. So right now we have to add those. So that way that our particles or our voxel would have time to hit the wall of the collider before it bounces back. So it doesn't just go past through it. So that is what step size does. So basically everything has it. So end cloth has it, end particle also has it. So since in end particle we didn't have that much of collision, so because we're using object rather than point, rather than the point voxel particle system, so it's not really that hard for it to collide. So for like point form here, what we need to do is just change the amount of steps. So basically that one frame, you're gonna add more steps for it to simulate. So instead of simulating one frame, it's going to simulate 2 or 3 frames. So one good thing about this is, of course, you get your collision better, but one negative part of it is, so instead of simulating, processing one frame, so now it's going to be processing multiple frames. So basically within that one frame, it's going to process more. So your simulation time is going to be more, your RAM consumption is going to be more as well, because you need to save each of those steps in between the frames. So to do that, basically we're going to open up, going to select back our Bifrost liquid. We are going to go to liquid shape. Bifrost liquid containers. So here it is. Transport step adaptivity. So basically it's the same thing. It's just that if there's like for simulation anything with steps, it means that you gotta have to add those for like this passing through stuff. So right now it is set at 0.32. Basically, every frame is already have 3 additional simulation in between it. So right now, even with that 3, it still passes through. So what we now can do is just 0.4 or 0.5, it depends. So you want to add this gradually. If not, you're going to wait forever for your simulation, because it's simulating more and more between each frame. So just going to put it at 0.5, just a little bit more. So now we're going to start simulating again. So now you can see that all of our particles, our voxel point is no longer passing through our basin, our container. Now it's going to flow. So we'll pause this and look at it frame by frame. You can see here the water is coming out from the top rather than from the side. So it's not passing through your basin anymore. So now you can see, if you were to look at it from different angles, you can see how the water behaves. So yeah, basically that is what liquid does. So the only thing that you can change is make it thicker or thinner. Actually, you can't make it thinner. You can just make it thicker. So to make it thicker, let's say you want to make it thick like not as much, maybe what, honey or blood. Blood is thicker than water. So to do that, you can just scroll down to viscosity. So it is viscosity. So if you were to put 1 here, and then you try to simulate it again, you can see the difference of how basically the thickness of that simulation. So it's not going to, so the more, you can just make it more, let's say you put it at 2, so the more you add it in, the more thicker the water voxel becomes. So if you look at here, right now at 60 frame, the water only moves this much, or the liquid doesn't just move this much. Whereas if we were to use, we were to turn off water viscosity here, and then start simulating, so it moves way faster. So now it's overflowing. So yeah, pretty much that's the only setting that you have. There are other settings, but the only basic that you need to use is how much is flowing, how big is the particle size, and how thick the liquid is. Is it going to be like water thick, or is it going to be like blood or honey kind of thickness, or lava kind of thickness? So basically, you can just change that. So now you can see here, we are still looking at it in like this dotted point form. So we want to see it in like actual mesh liquid form. So to do that, all we have to do is go to liquid shape. If you go to liquid shape where the point size is, so if you were to change the point size, you can see here if it's like 1, it's really small. So you can go up to 10. So 10 is just ridiculously big. So you can't see actually the shape of the flow. So that's why I usually just use 5. So at least when you zoom in, you can still see it. You zoom out. So then if you were to scroll down and look for Bifrost meshing, open that tab. So you have this enable. So if you click on enable, it will turn it into liquid, into mesh liquid. And it's all triangulated. So we want to go back, liquid, scroll down. So here are a few settings that you have. The most important one is smoothing. Just so you know, if you put it at 3, your computer might hang or crash. So I have 1. So right now, 2 is the, unless you're doing, if you have like a really powerful i9 with 5080, then you might want to go to 3 or 4. So if you're just using your laptop, stick to 2. So like I said, Bifrost is the most processing and RAM consumption of all of the other simulation engines. So we haven't touched with Fire yet. So just make sure it's stuck at 2. If you want to try it later on and want to see how your computer hangs, you can just take it up a little bit. So droplet removal factor, basically you can see here, based out of each of the points, it's trying to create a mesh. So if, like each point has its own, maybe a shape of a mesh. So the closer it gets, it's kind of merged together. So if there's like multiple ones, so it's just merged and turn it into a mesh liquid form. So you can see here, if I were to put less, if I were to put more, it's going to be like really big. So we want to just maybe try the default one first, which is 3. So it's the same thing with radius. You can see here.